Good morning. Let's start with today's session. Okay, let us go to the next step. So here I have made that optimum speed diagram which is selected. So again I will name it. And here if I am writing speed diagram, I will name it like this: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. Because I am writing what? Speed diagram. I am not drawing now the structural diagram. Structural diagram में top to bottom, speed diagram में bottom to top. Okay. Then here we have input speed to the gearbox is given by. Okay, so this is my input speed. And if I don't give this speed, my gearbox will not work, or my designed gearbox will not work. So what will be the formula? बताया था मैंने. What will be the formula? Before that, can someone of you tell me the speeds at various locations? What is the first speed? I think 24, 20. जो हमको क्वेश्चन में दिया था, minimum speed is 20 and maximum speed is 894. Okay, so I need the middle speeds. For those who have solved it, can tell me what are the answers here at this particular stages?
From bottom 28.
Yeah, 28,
40.
40,
632.5.
632.5. Perfect.
Right.
So these are the answers of the various speeds. Now I need the speed exactly in between 6 and 7. So most of you, what you do is, if I tell you to find out the speed between 6 and 7, so what you will do is 159 plus 112.5 divided by 2. So that is the algebraic sum. Mind well, that is the algebraic sum, and we have the distance between these two is not an algebraic sum, it is a geometric progression. We from this speed to this speed, we have followed a geometric progression, hence the normal arithmetic mean will not work here. So what is the formula now? Here it will be log of ni. Log of ni means input speed. I will write out ni here in the diagram. Log of ni is equal to, can I write it as log 6 log n6 plus log of 5 by 2. Correct? Because it is at the center, so it will be log of 5 by 2. This formula can also be written as, the other way to write this formula will be log of ni is equal to log of n7 minus log of 5 by 2. Both the formula will give you the same answer. Either you write n6 plus 5 by 2 or you write n7 minus log of 5 by 2. Both of them will give you same answer. So log of n6 will be log of n6. So it will be 112.5. And plus log of 5 is how much? Apna tha 1.412 something. Log of 5 divided by 2. Again, mind well, here student make the mistake, they do log of 5 by 2. It is not log of 5 by 2, it is log 5 the whole divided by 2. Okay, so quickly give me this answer. What is ni coming?
सर वहाँ प्लस आएगा या माइनस आएगा?
अगर n6 ले रहे हो तो प्लस आएगा ना. देखो मेरे को 112 से ऊपर जाना है, somewhere here, तो it will be plus. But अगर मैं ये लिखता हूँ n7, so I am coming down, so it will be n7 minus. अगर n6 लिख रहा हूँ तो प्लस आएगा, n7 लिख रहा हूँ तो माइनस आएगा. So what will be ni?
135.
Okay, 135 rpm. So here I will write ni is equal to 135 rpm. And with this, what I am telling to my customers, that for my gearbox to work, I need the speed or the input speed to be as 135 rpm. अब उसके पास कोई भी मोटर है, उससे हमको मतलब नहीं है. For our gearbox to work or function properly, I need the speed to be, or input speed to be 135 rpm. So what we will do here is, we will select some mechanism here. We will tell him, okay, can you tell me what was the motor speed given to us in the question?
1440.
1440. So somewhere here I will mark, somewhere here at the top I will mark that this is a motor speed nm, that is 1440. So what I will do is, I will just mark a ray here. I will just mark a ray here, indicating that I need some mechanism here which you select what you want, whether it is belt drive, pulley, chain drive, whatever you want, gear, etc., etc. But I need my input speed to be 135 from 1440. And at least for simplicity, what I can do is, I can give him the reduction ratio. Okay, what reduction ratio he should apply? So for reduction ratio, what is the answer? What is the formula? Reduction ratio is equal to what? It is simple. It will be RPM of motor divided by input
divided by
RPM.
135.
So it will be 1440 divided by 135. So what will be answer here?
10.6.
10.6. Okay. So that you can use any mechanism with a reduction ratio of 10.6 so that we can get our input speed at 135, and so that you can get the required speeds which you desire. The next step is calculate the number of gear pairs, and that depends on the structural diagram. So we have the structural diagram with us, and also I have given you the shortcut that the number which is outside the bracket, the number which is outside the bracket gives you the gear pairs. The number outside the bracket gives you the gear pairs at that particular stage. That's a simple thing. So I can write here with the same logic, gear pairs at stage 1 is 2. Okay, so I will write it here, gear at pair stage 1 is equal to 2, gear pair at stage 2 is equal to 3, and gear pair at stage 3 is equal to 2. Then we have to find out total gear pairs. So total gear pairs will be 3 plus 2 5 and plus 2 7. So mind well, again, these are the number of gear pairs, not number of gears. These are gear pairs. So if I want to find out number of gears, it will be just 2 multiplied by 7, which is equal to 14. So from here, what we came to know is we have to design a gearbox which is having 14 number of gears. And if it is having 14 number of gears, we have to find out or do the calculations for number of teeth for 14 number of gears. So let us start with that.